This video will cover your textbook 6.4 and 6.5. Let's start out by looking at these two triangles. These are two congruent triangles, triangle ABC and triangle A prime, B prime, and C prime. Now, how do we know that these are congruent? With congruent triangles, all of their angles have to be congruent to the corresponding angles in this other triangle, right? And same is true with all of their sides. So AB and A prime, B prime have to be congruent, AC and A prime and C prime, and BC and B prime and C prime has to be congruent. So that's for congruent triangles. Now, for similar triangles, look at this example. For these two, obviously the sides are of different length, but the angles have to be exactly the same. They still have the same angles, or rather congruent. All the corresponding angles have to be congruent. Congruent angles. And the sides, as we learned in the previous unit, the sides have to be proportional. And the way to verify that is to calculate the scale factor. So they have to have the same scale factor. Okay, so those are the two essential things. For congruent triangles, we have to have congruent angles and congruent sides. For similar triangles, we still have to have congruent angles, but we have to have proportional sides. Proportional sides have the same scale factors. So in this unit, we're going to learn three unique and very helpful theorems, AA, SAS, and SS similarity theorems. So let's start out with AA. Just a note that follow these numbers, because I jump around a little in this slide. So AA similarity postulate states that if two corresponding angles are congruent, then the triangles are similar, which means in this example, angle A and angle D are congruent at 75 degrees, and angle C and angle F are congruent at 31 degrees. Therefore, I can state that triangle ABC is similar to triangle DEF, and that's by AA similarity postulate. Okay? Notice that the order of how you write the triangles matters a lot. A is corresponding to D. Angle A and angle D are corresponding to each other. And angle B and E corresponds to each other, and that's in my writing as well. And then finally, my angle C and angle F corresponds to each other, and that's the last letter I used in describing both triangles. So let's look at this example. I have angle V and angle Y are congruent. I'm not given any more information, but by vertical angle theorem, I know my two vertical angle, I'm going to call it angle A and angle 2, are congruent. So therefore, by AA similarity postulate, I know that, careful with the sequence, VXW is similar to triangle YXC. You don't have to start with Y. You can start with Z in this triangle. But if you start with Z in the other triangle, you have to start with W. Okay? As a visual person, I often go by, because I have this 1 ticker, 2 ticker, 3 ticker, or nothing. 1, 2, 3, or nothing. So that makes my life a lot easier. Let's look at some examples here. I will leave number 6 to you to practice because it's exactly the same as the example that I just did. Look at this triangle. I have this example, number 3. I have angle Y being congruent with angle C because they're both right angles. But this angle E is 39, if this angle W is 51, so they're not congruent. So I'm tempted to say that they are not similar. However, just to be careful, I want to find out what this angle S is worth. And if I have angle, because the measure of angle S plus the measure of angle E plus the measure of angle Y equals 180 degrees. And because Y is 90 degrees, E is 39 degrees, I can now easily solve for angle S. With some algebra and arithmetics, you will find out that angle X is 51 degrees. Now, angle S is congruent to angle W. So I draw the conclusion that angle S is congruent to angle W. I made a mistake here. It should be congruent. So now I have my A, right? So by A similarity postulate, triangle EYS is similar to triangle HCW. And that's my final statement right there. Final solution right there. This is my similarity statement. Okay. Let's look at some other examples by AA similarity. AA is pretty straightforward. A lot of times you're either given the angle measures like the first example we did, or you're asked to calculate all 3 and then find out if 2 of them or 3 of them are congruent. And another type of question you'll be asked is these parallel lines. These are really interesting because they create opportunities. Look at number 1. The only thing given is the parallel line. Now we know, obviously, I'm going to call this angle 1 and angle 2. We know angle 1 and angle 2 are congruent by vertical angle theorem. And there's no other information given about angles but the parallel lines. If I look at the parallel lines, I can say that of these parallel lines, I can say CG cuts them through, right? If I see if I can do this a little bit more elegantly by using lines. So if I do CG right here, this is a transversal. And when I have parallel lines and transversal, I have angle 3 and angle 4 being alternate interior angle. And I can say angle 3 and angle 4 are congruent as alternate interior angles because these 2 lines are parallel. We learned that in chapter 3. Now, because of this, I have by AA similarity postulate, I can say that triangle CED is similar to triangle GEF. Again, pay attention to the sequence that you use. Okay, so that's how we use the parallel lines. And let's look at the second example. I have parallel lines. I have ML as my transversal. I'm going to call this angle 1 and angle 2. So I can say angle 1 and angle 2 are congruent. But notice LN is also a transversal, a separate one. So I can draw the conclusion that angle 3 and angle 4 are also congruent, right? Because 3 and 4 are corresponding angles along the transversal NL. 1 and 2 are corresponding angles along ML, a second transversal. So therefore I can draw the conclusion that triangle LPQ is similar to triangle LNM. That's my similarity statement. Okay? Now, let's assume that you stopped right here. Let's assume that you decided that you only saw one transversal, ML, and figured out that angle 1 and angle 2 are congruent. And then you jumped straight ahead to say angle L is the shared angle by both triangles. And angle L is congruent to angle L. And you can draw the same conclusion by AA, just two different angles. In other words, with AA similarity postulate, we're really saying it's AAA, right? All three angles have to be congruent in similar triangles. Now let's look at SSS. SSS similarity theorem states that if corresponding sides, all corresponding sides in one triangle is proportional to the other triangle. In other words, if I calculate the scale factors, all three sides have to have the same scale factor. Then these two triangles are similar. So let's look at this example 3. I have a really quick and dirty way of setting this up. What I do is I look at, because three sides are given, most likely I'm going for SSS. So I write out the smallest to the largest side. And then I go to the second triangle. I do the same thing. This time I do it in the denominator. So it's 6, 8, 10. 6, 8, 10. Then you simplify them. See if they come down to the same fraction. They all come down to 1/2. In other words, all three sides are proportional with the same scale factor. Their scale factor is 1/2. And therefore, I can draw the conclusion. Be careful with your sequence. PQR, triangle PQR, is similar to triangle STU. And that is my similarity statement right there. With the second example, again, I do the same thing. I list out this side length from the smallest to the largest. And then I go for the second triangle. I list them out from the smallest to the largest. And if I cancel by 6, I should have 5/4. And see, this is the problem here. There's no way I can make 32/25 5/4. So therefore, the answer is no. These two triangles are not similar. Let's look at some other examples. I will leave 7 for you to complete because it's exactly the same as what we just did in the previous two examples. In this type of, number 8, in this type of example, pay attention to the small triangle is embedded into a big triangle. So you just have to pay attention to all three sides. And let's look at the small triangle WVX first. Three sides I have 15, 20, 40. 15, 20, 40. And then in the big triangle WUY, I have, notice that 8 is only this part. So this whole part is 20 plus 8. So this would be 28, and this side would be 21. 21 is less than 28, and 56 being the largest. Now you start reducing. This would be 4, so that looks good. This would be 8. 8 is, so all of them get reduced to 5/7. So, which means, yes, these two triangles are similar. So again, be careful with your sequence. WVX, is not congruent, is similar to triangle WUY. Okay, so that is my similarity statement. And if you want to add to it, you can spell it out by saying by SSS, Similarity Theorem. I will leave you to do 9, and I'll do number 10. Number 10 is just two triangles flipped. Doesn't matter how they present the triangle, still the same way. Look at the triangle on the left, go from the smallest to the largest. Now look at the triangle on the right, go from the smallest to the largest. And start reducing. 3, that's 5, 3, 1, 3, 3, 8 is 28. So this works, right? This is a little bit more tricky. I'm going to bring this to this side. 12 over 43.2. The first thing you want to do is to get rid of this decimal point by moving it to the right by 1 digit. In other words, multiply the denominator by 10, you will get rid of that decimal point. And if I multiply the denominator, I have to multiply the numerator. And now from here on, you can keep canceling, and you will find that you will come up with the same scale factor. And therefore, the answer to this one is yes. But be very careful. Go for the smallest size since you went small to large. So you can do PRA. Triangle PRA is similar to, and then you do this side is YRT by SSX. That's your final answer right here. Okay. The last theorem, SAS. SAS is not complicated, but it does incorporate strategies that we just used in both previous theorems. So it says that if I have two corresponding sides are proportional, this we already know, this statement is in all the previous ones. If two corresponding sides are proportional, and then the included angle are congruent, and this is really important. I want to highlight this. Included angle, meaning the angle has to be sandwiched by both sides. You cannot be just have one side. Half a sandwich doesn't count. So let's look at some examples here. I have two triangles, angle K and angle N is congruent, are congruent. So I satisfied my A here. Now I have 8 on this side, I have 6 on this side, and I have 20 on this side, I have 50 on this side. I do the same thing. I have to calculate my scale factors, so I lay them out. I go, just like what I did previously. I go from the smallest to the largest in the first triangle. Then I go from the smallest to the largest or larger one in the small triangle, and you will find out that they both can be reduced to 4/3. Therefore, the answer is yes. So by, you can write this as JKL is similar to triangle MNP, and this one would be SAS, similarity statement. So again, notice that I have my SAS here. SAS. That A has to be sandwiched in between the two sides that I have information on. Oops. Let's look at the second example. This one, I have a sheared angle. So the A is right there. So angle A is congruent to angle A already, right? The rest of it is just calculating the scale factor. So in the small triangle, I list out the shortest to the longest. In the bigger triangle, I list out the shortest, 21, to the longer one, 25. And now if I reduce it by 3, I would have 4, and that's 7. 5, yep. So these two do not equal each other, and the answer for this one is no. These two triangles are not similar. Okay? 12. Oh, let me go back. If I I think I may have made a mistake there. In this small triangle, no, I didn't. That's right. So 21, yep, this is correct. Sorry about that, guys. So let's do some practice here. In example 13, I have angle 1 and angle 2 being congruent because they are vertical angles. So I've got the A already. I have two sides. In this small triangle, shorter one is 6, longer one is 12. In the other triangle, I have 24, and the longer side is 48. So you lay them out and start reducing, and you will find out that they do equal each other. So therefore, yes, you can say triangle SER is similar to triangle, I started with the longer side, so it will be GEF. That's my similarity statement, and that similarity is SAS. This is SAS similarity theorem. Okay? Finish question 14 on your own. It's exactly the same type. And this, I would argue, is exactly the same type as well. The only difference is that you need to calculate the length. You need to calculate the total length of AD. You just do 12 plus 8, which is 20. Number 17 is the same, so I'm not going to do it. And finally, this one, let's look at this one. I really have two triangles here that I need to look at, right? I have PRQ or PQR. That's one triangle. Oops, how come that didn't work? Was trying to do the shape recognition. There we go. Now I have PQR. That's one triangle. And then if I use a different color, I would have MPC. That's my second triangle, right? Now, if, see if I can draw this a little better. PQR. Oops, didn't do a different color. This is where I try to be fancy, but doesn't always help myself. There we go. It's about as good as I can get. Now, I know two sides in the blue triangle. I know two sides of that red triangle. So let's set up the proportionality first. I'll start with the red triangle. I go from the smallest to the biggest. And now I look at the blue triangle. I also go from the smaller one to the bigger one, or biggest one. Now I try to simplify it. If I do cancel it by 2, I would have 11 over 18. In this case, I cancel by 3. I also have 11 over 18, which means they are proportional. They have the same factor. And so now I've got, out of the SAS, I've got one side and one side. All I need is an angle. I don't see the angle given here. So what should I do? And here's the piece of information that you haven't used. Okay, so let's see if I can get rid of this now. We finished using those angles. Here's the piece of information you haven't used. These two lines are parallel. So if you look at MQ as the hypotenuse, this is not easy to see. Ignore this one. Suppose that yellow part is not there. Suppose that I only have two straight lines right here that are parallel, and then right here that are parallel. And then now you can see that this is my transversal. If I do that, I can say these two red angles, angle 1 and angle 2, are corresponding angles. So I can say, because these two lines are parallel, angle 1 and angle 2 being corresponding angles are congruent, right? And angle 1 and angle 2, now if I just erase all of my references, erase the yellow part, let's erase the yellow part. And if I also take away the red part and you still have the black ink underneath, then you will see that angle 1 and angle 2 are the interior angles right here. They're corresponding in each of the triangles. So here is my A. So by SAS similarity theorem, triangle PQR on the right is similar to triangle MPC. That is my similarity statement. Okay, so again, use everything that you're given. What do I mean by that? Because two sides are given, you calculate the scale factor. And then you have an A that's missing, so you go look for the missing one, missing information. And because the only given information that you haven't used is the parallel lines, so it's easy to relate that to the 4 theorems we talked about regarding alternate interior, alternate exterior, corresponding angles, and same side interior angles. Okay, so that's 6.4 and 6.5. If you need additional information, just send me an email. Thank you, guys.